Guys, look. This is the fuel injection pump. This fuel injection pump, the fuel coming from the low pressure pump, the fuel enter here. And this is the fuel coming out at high pressure per each injector. Everybody follow me? Output, and this is the input. And here, what is this? What is this? What is this? The start-stop solenoid. If you apply power here, you hear. This is the solenoid that allows that fuel enter or no enter. Start or stop. The governor is here. And the pump is here. That's clear? What type of pump? Later we are going to talk about that. This is a rotary pump. And the other one, the mini replica mini engine, is inline. Both of them are the same. Okay, in this pump, pay attention. Follow me, guys. In this pump, if this generator, if this engine is running with a generator, with a backhand, the RPMs are fixed in one position. In this moment, this is the fuel injection pump of this engine. It's running at 1500 RPMs. You see here, you have a safety wire and you have 2 bolts. I am going to cut it, the safety wire, and I am going to lose both bolts to adjust the RPMs. One bolt is for idle, low RPMs, and the other bolt is for high RPMs, wide open throttle. Wide open throttle and idle. I am going to cut the wire. Let me bring the cutter wire, and I am going to explain after that the process to do the safety wire again. Okay, guys, follow me. Look, I am going to cut it, the safety wire. What is the purpose of the safety wire? Avoid that one Mickey Mouse technician moved the RPMs. Because some technician with no acknowledge, when they have low voltage, they think that if they increase the RPMs, the voltage goes up. Because they move it a little, the RPMs, and the voltage increase a little. And they think that if they added more RPMs, probably they have more and more voltage. No, the voltage, when you modify the RPMs, increase a little, but stay over there. Doesn't matter if you continue increasing the RPMs. And they continue increasing the RPMs and change the frequency. And after that, you have other problems, all right? Never touch that bolt because you modified the frequency. Okay, I cut it, the cable, the wire, and now my bolt for wide open throttle is open. I start the generator is running, I cut this, I lose the bolt in the bottom. You see, it's a bolt with 2 nuts here. One to lose and other to fix it. Okay, and now I am ready to move it with my hand, that bolt. The generator is running, I connect in the breaker, in the output breaker, my voltmeter in the breaker, and I change to frequency. And I see the frequency, 50 Hertz. The generator is running, the AC panel with no load. That's clear, guys? All right, and now I start moving, 51 Hertz, 53, 55, 58, 60. Normally, I let in 61. And I tight a little with my hand. And now I go to the AC panel to apply load, a little. And I hear the gain, AC, gain, AC. And the voltage stay 120 and the frequency 60 with full load in the panel. Let me remove the load. Bam, 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 bam. No load. And once again, load. 120, 60 Hertz. That's perfect, my conversion. You understand, guys? And after that, I finish. I tight that one, and I am ready to put the wire. I'm going to do that. Okay, guys, look. I need a safety wire where you can buy that wire in any aviation shop. This is for aviation. In aviation, it's very common. Okay, and you can buy this one in different thickness. No, this is 0.02, 0.03 millimeters, the thickness. Okay, I am going to prepare, and you need an special pliers for safety wire. Alright guys, look at this. I cut it one portion of the wire. If you see those bolts, the head is drilled. You can pass the cable. You see guys? Alright, I am going to pass the cable here, the wire, and I am going to check how much distance I need between this bolt and this bolt. You see guys? And here, in that point, I am going to
Nice tool.
okay.
That's convenient.
And now I open my tool, I pass the other end, I pass the other end here, and now I twist it a little here, and once again, bingo finito. Nobody modify my RPMs. Good, papas?